Well, hey everybody, it's Mr. A, and hope everybody had a great break. Ready to get back in the swing of things here. Our next topic in Algebra 1 is our next to last topic, actually, is how to solve quadratic equations. And this topic is actually the lengthier of the last two, so hopefully we get through this one, and then in May we'll do our last topic, and we'll be done with Algebra 1. So without further ado, let's go ahead and talk about a little bit quickly about quadratic equations, and then over the course of the topic, I'm going to show you three different solving methods that you're going to have to be able to perform for me on your next assessment. All right, so let me get started with the first method in the first video, and then we'll do another video for each of the other methods. So for this video, let's start with talking about what a quadratic equation is. And we've used this term quadratic before when we were classifying polynomials. And if you remember, a quadratic equation has a degree of 2. So the highest exponent on one of the terms is 2, as indicated here by the arrow. Degree is 2. Now, when we're solving equations, the degree of the polynomial in the equation also tells us some very important information. It tells us that this is the number of solutions of the equation. And this is a very famous result called the fundamental theorem of algebra. So basically, in its simplest form, it says an equation to the nth degree has n solutions. So a equation to the second degree has 2 solutions. So we will be able to know right away how many solutions to expect when we solve these, because we'll be able to see our degree on our polynomial. All right, so quadratic equations, degree of 2, so we should be expecting 2 solutions, okay? Now, one of the tools that we have to be able to do when we solve these equations is something called the multiplication property of 0. Now, you guys learned this a long time ago in grade school, but we're just going to hit it again here real fast because we're going to apply it to some algebra ideas. So the property just basically says that if 2 things multiply to get 0, then either one of the 2 items must be 0 for that to happen. And there's no other way to get 0 unless one of the items that we multiply is 0. Okay? So why is that? Well, let's say that A is 0. So if A equals 0, we would have 0 times B, and that would equal 0. Likewise, if we have B equaling 0, then we would have A times 0, and that would also equal 0. And of course, if they both equal 0, we would have 0 for A and 0 for B, and of course that equals 0. Why is this important? Because the first method we're going to learn to solve quadratic equations is by factoring. So it takes everything we learned in the last topic, and now we're going to apply that information with this property and solve quadratic equations that are factorable. All right? So I have a little example. I have a couple of mini examples here to get us started. So the first one is right here on page, right here on page 1, on page 2. Notice that this equation is already in factored form. I already have the factors for you. All we're going to do here on this equation is we're going to apply the multiplication property, okay? So if I let the first grouping right here, let that be A, and the second grouping right here, let that be B, then I can apply the property. All right? So when we solve these equations, what I like to try to do is I'm going to draw a line between the factors, just like so, straight line, and then I'm going to set each factor equal to 0, because if the whole equation equals 0, which it does, okay, which it does right over here, okay, then we know from the previous property that in order for that to be true, then at least the blue group or the red group must equal 0. And that way I can get solutions to this equation. So I'm going to take the blue group, x minus 3, I'm going to set it equal to 0, okay, and then basically solve for x, add 3 to each side, and I get x equals 3. Now, let's check that out here for just a second. If I plug in 3 for x in both groups, look what happens. So I have 3 minus 3 in the first group, and then I have 3 minus 5 in the second group, okay? And this is our check step again. So we're going to have 0 times negative 2, and that equals 0. So then 3 is a solution. Or, let me fix this box here, or we call that a root of the equation. All right, solutions are called roots. Likewise, over here on the other side of the line, if I do x minus 5 equals 0, add 5 to each side, I get x equals 5. And if I go to check that one, then I would have 5 minus 3 times 5 minus 5. That'd be 2 times 0, and again, that equals 0. That's how we use the zero product property to solve these equations. So once we get our, as you're finding out here, once we get our expression factored, we're going to set each factor equal to 0 to solve the equation. And those are the two steps combined, the factoring techniques that we learned from the last topic, and then this new little property here. Those are going to be the tools we're going to use to solve these equations. All right, so I got another little exercise here for you. Right here, we're going to try this one here real fast. What we're going to do is just practice it real quick, and you're going to just duplicate the process I did on the previous problem. So I'm going to pause for a minute so you can pause your video, and you can practice this on your own, and then I'll go through it with you real fast before we go on and show you the entire process for how to solve an equation by factoring. So pausing right now. All right, guys, so hopefully this one didn't throw you off too much. I'm going to go ahead and just color these in again so we can talk about them. So we have our blue group right here. That would be our A. And then we also have our red group over here. This one would be our B. Okay, so then we are going to, again, draw a line down the middle here, split them up. So over here on the left side, we'd have x plus 4 equals 0. Subtract 4 on each side. And our final answer over here would be x equals negative 4. That makes the blue group equal to 0, so we know that's a solution. Okay. Now over here on the right side, we'll set that group equal to 0. So 2x minus 3 equals 0. Add 3 to each side. And then we still have 2x equals 3. So this is a two-step solve. Cross those out. Final answer, x equals 3/2. Those are the two values for x that make these groups equal to 0. So those are the two values, or the roots of the equation. All right? Now, we're going to put it all together and have one step-by-step method to solve an equation by factoring. Okay? So here's the method. We're going to go through it here together. Okay? So, number one, this is very, very important, and we're going to talk about this as we do our next few problems here. We need to make sure that one side of the equation is always equal to 0, okay? Otherwise, that messes up the factoring process, so we want to make sure that we have the correct numbers when we're trying to factor the expression. So make sure that you factor or have one side equal to 0. And if you notice in parentheses here, I said other side in standard form helps. It really does, okay? So if you have the other side written in standard form, big advantage when you try to factor, which is step number 2, okay, to factor the expression that you have completely. So the expression that's on the opposite side of 0, factor it as far as you can, okay? And then on step number 3, you're going to set each factor equal to 0, That includes GCFs that you might factor out that have variables in them. Okay? So make sure you set each of the factors equal to 0. There could be more than 2 of them. And last but not least, you're going to solve each of these little equations that you make from step 3 to obtain your final roots. All right? Now, I have 5 examples that I want to go over with you. I have 5 examples, but I'm only going to go do the odd ones with you. I'm going to say the even ones for you to do on your own. And then we have a word problem at the end we're going to do as well. And I'll wrap up the first video. Okay? So let's go ahead and take a look here at example number 1. All right? So we're going to go through our checklist here, make sure that we are all knowing what's going on here. Number 1 said to always make sure that one side of your equation is equal to 0. Well, we have that, so we're good. This side's equal to 0, so that's great. So what we're going to do now is we're going to factor this expression over here, okay? So when you factor x squared plus 2x minus 15, use your factoring techniques. You can use ABC method. That works just fine. Or there's a shortcut for this one. You can also use that as well. If you do A and C together, that's negative 15. And you need a factor pair that adds the 2. So if I'm thinking about this correctly, that's going to be positive 5 and negative 3. All right? So I'm going to go ahead and do this the long method again just so we can get the factoring review. So I'm going to split up the middle term. So x squared plus 5x minus 3x minus 15. Bring down the equal 0. Okay, that's important. Now it's an equation. It's got to keep it in an equation. So now we're going to factor by grouping. And if you remember the shortcut for these, for A is 1, then you can do the shortcut too. I'm just reviewing some factoring here so we have a chance. So GCF the first group, we'll have x. Left over, we'll have x plus 5. GCF of the second group is negative 3, because I need to keep the signs the same. So then I'll have negative 3 times x plus 5. All right, and if I notice here, my groups match. This is an x plus 5 here. This is an x plus 5 here. So then my factoring is going to be x minus 3 times x plus 5 equals 0. Okay? That's the factoring part. Now that we have the factors, we're going to do step 3, which is set each one of those equal to 0 and get our roots. So I'm going to go ahead and split this up right down here. These are quick ones, so I don't have to have that much room. So I'll set x minus 3 equal to 0. Add 3 to each side. I get x equals 3 for the first root. Okay. And then over here, we'll do x plus 5 equals 0. I'm going to subtract the 5 from each side. So then I get x equals negative 5 for the second root. And you can plug these back in. In fact, you can plug it in up here to the original equation too, if you want to. I'll do that one with the negative 5, so you can check it real fast. We'll do negative 5, okay? So I'll do negative 5 squared plus 2 times negative 5 minus 15, or we're going to see if that equals 0. Okay? Negative 5 squared is positive 25. 2 times negative 5 is negative 10. Minus 15. Check that out. 25 minus 10 is 15. And 15 minus 15 is 0. So it checks. And that's how we know that those are the solutions or the roots to this equation. All right? That's example 1. Now I'm going to go ahead and look at example 2. Okay, in example 2 here, if you notice, over here on the right side, we don't have a 0. Okay? So in order to get this equal to 0, we have to make one side equal to 0. And what we need to do then is we need to move this negative 4 over to the left side. in order to get one of these sides of the equation equal to 0. Now, you don't have to move always to the left side, but what I tried to do is to make sure that my a value, which is 3 in this case, remember that's a, try to make sure that a always is positive, because if we learned from the previous topic that when a is positive, things are a lot easier to factor. So usually the best way to go is to make a positive in this case, okay? So in order to get one side of the equation equal to 0 for this problem, we're going to add 4 to each side, okay? Now there are no like terms on the right side or left side to combine with 4, so we're just going to write it down. 3x squared plus 7x plus 4 equals 0. Okay? And then I'm going to let you finish this one out. I have the answer key to my notes posted so you can see it. And you can use that for reference if you need to have all the problems worked out. So that should be able to help you out with problem number 2. All right? And you can then solve it and see if you can figure out what the answers are. I'll tell you what. I'll even put the answers up here real quick. If you get the answers of x equals -1 and x equals -4/3, you solve the equation correctly. Okay? So those are the roots. All right? Moving on to problem 3. Now, problem 3 is very interesting because on problem 3, first of all, one side is not equal to 0. And second of all, you might notice that we have a cubic term in our equation, which means we should have 3 solutions this time. All right, because remember we talked about that at the very beginning of the video, that the highest degree on a term tells us how many solutions we're supposed to have. All right, so we're still going to follow the same method. We're still going to set one side equal to 0, and we're still going to factor this expression when one side is 0, and it's all going to work out. But this time we should anticipate 3 solutions to our problem. Okay, so let's start out and move the terms on the right to the left side so that a stays positive. So I'm going to subtract 8x squared. And again, these don't have anything to combine with, so we're just going to rewrite them. And subtract 8x, okay? So they cancel out there. So I'm left with 30x to the third minus 8x squared minus 8x equals 0. Okay? Now, if you remember your factoring, I'm just moving this over for a few minutes. If you remember our factoring techniques, you should remember that the very first thing we always look for when we factor is a greatest common factor. So, I'm looking at the terms, okay, and it looks to me like the GCF of the numbers, 30 and 8, is a 2, and there's an x at least shared in each of the terms, so the GCF is going to be 2x. And when I factor out 2x, I have 15x squared minus 4x minus 4 equals 0. Okay? So we're going to factor the group now in parentheses. Don't forget to bring down your GCF in each new line. We'll do a little scratch work over here. Okay, we're going to do the ABC method on this one. So we'll do 15 times -4. That's -60. Okay? And I need a factor pair of -60 that adds the -4. Can you think about which one that is? It's -10 and +6. All right? So we're going to split up the middle term. Okay? So 15x squared minus 10x plus 6x minus 4 equals 0. Now I need to change this to a bracket. There we go. All right, now we're going to factor this by grouping, so I'm going to change color. Okay, so we can do the grouping here. So I have 2x bracket. GCF for group number 1 is a 5x. Left over, I have 3 x minus 2. Okay, in the second group, since the signs align, I'm just going to pull out a positive GCF, which is positive 2. And then factor the remaining 3x minus 2, like so, equals 0. The groups match, which is great. So then my final factorization is going to be 2x times 3x minus 2 times 5x plus 2 equals 0. Now, I'm going to switch these groups around a little bit. I kind of got them out of order. So give me just a second to switch them around. And we'll come back. There we go. Okay, not that it matters, but just to be consistent. All right, so I'm going to switch colors again. I'm actually going to set this equal to 0 here, and I'm going to copy this line. Whoops, copy. Cut this line and copy it. We're going to move it up to the top row over here. So then I'm going to take each one of these factors, okay, and set it equal to 0. So I'm going to do a little division right there, and again right there, and I have to write real small here. In fact, this probably is not going to work, so I'm going to have to just rewrite this again. So I'm going to say each factor equal to 0, and then I'll draw my line. So 2x equals 0. Okay, so there's the first one. Okay, then I have 5x plus 2 equals 0. And then, try that one more time here. And then I have 3x minus 2 equals 0. Okay, so then I'm going to divide both sides by 2. So I get x equals 0 for the first one. Remember, we're supposed to get 3. And then we're going to get 3 because we have 3 factors to set equal to 0. So then I'm going to subtract 2 there. I get 5x equals negative 2. Divide both sides by 5. I get x equals negative 2/5. I'm going to write that a little bit clearer. There we go. There we go. And then over here, add 2 to each side to get 3x equals 2. Divide both sides by 3. I get x equals 2/3. So the three solutions to this equation are 0, negative 2/5, and 2/3. So those are the 3 roots. Okay? All right. That's about as intense as they can possibly get. But there's a special case I want you to talk about on example 5. So I'm going to actually leave example 4 for you to do on your own. I'm not going to tell you the solutions to that. You can check that out in the answer key if you want to. We're going to scoot on to example 5 here real fast. I'm going to do this one real quickly just because I want to talk about the solution here real fast. Okay? So it's already set equal to 0, which is great. And we're just going to go ahead and factor it real fast. So multiply 4 and 9 together. So 4 times 9 is 36. Okay. Factor pairs negative 6 and negative 6. They add the negative 12. So we're going to split this up. I have 4x squared minus 6x minus 6x plus 9 equals 0. So group them together. And then pull out the GCF of the first group, which is a 2x. Left over is 2x minus 3. Second group, you're going to have to switch the signs because the signs don't match up. Okay, so pull out a negative 3, and then 2x minus 3. This equals 0. All right, and then finish the factoring. You get 2x minus 3 times 2x minus 3 equals 0. Now, you notice this time both factors are the same. Okay, So you're going to get the same answer when you solve them. So I'm going to draw my line, just like that, and I get 2x minus 3 equals 0, and again, 2x minus 3 equals 0. So I'm only going to solve it once, because I know that they're going to be the same. So I get 2x equals 3, divide, and you get x equals 3 halves. Okay, and over here, you get the same thing. You get x equals 3 halves. Because it works out the same way. And since both solutions or roots are the same, notice that they equal each other. Okay, we call this a double root. All right, so the thing is that sometimes when we have quadratic equations, the roots can repeat themselves. And if it repeats once, it's a double root, and if it repeats again, it's a triple root. And you can have a quadratic or a quadruple root, those kind of things. Probably won't have any more than that, but depending on what kind of solution, what kind of equation you're solving, you could have duplicate roots. And sometimes when you solve these equations, the same root can appear twice. And in this case, it's one value, but it counts twice. So watch out for that when you do your assignment. Okay? Now, on the next couple of problems, these are real fast. Okay? I'm going to do this one with you, and then you're going to do the next one. This is just a quick one to just kind of remind you of what we talked about at the beginning of the video. How many solutions does this equation have? If you remember what we talked about regarding the degree of the equation, you should know this pretty quickly. I'm going to give you a second to make a guess. Okay, I'll pause for just a minute. Okay, so if you have your guess locked in, the degree of this polynomial on the left side is 4. Since the light set's equal to 0, that's going to be the expression. So without even solving it, I know that I'm going to have 4 solutions. Okay? You try this one. How many solutions should you expect if you were to solve this equation? Well, if you look at the degree, it's 28. So you should have predicted 28 solutions. All right? Okay, we are down to our last problem for this video. It is a word problem. So we're going to talk about the word problem, and then we're going to solve it. Okay, so I'll give you a chance to read it. Mark the text if you want to. I'm going to highlight the equation here, because that's going to become very important in what we're about to do. So I'm going to get it going here. Actually, I'm going to try to do a little bit better job than that. There we go. Because we're going to need that to help us out. All right, so this equation models how high a dolphin leaps out of the water. And what we want to do, first of all, is we want to figure out at what time or how many seconds pass when the dolphin returns to the water. So that is going to be our first major task. So there's 2 tasks to this problem. So we've talked about this a little bit before in previous problems, I think, when we had some function problems, that when you are when an object is on the ground, or in this case at the water level, then the height then of that object would be 0. Okay, so when it returns to the water, let me just highlight all of that. There we go. Then the height, y, because y is height, would be 0. So then all I have to do in order to determine the time here is use my equation, replace 0 with y, and solve for x. Okay? So that's what I'm going to do down here. So I'm going to start with my original equation. Y equals negative 16 x squared plus 32x. Okay? Replace y with 0. So 0 equals negative 16x squared plus 32x. Okay? And we're going to factor the expression on the right side. Now, if you remember me talking about this earlier in the video, I like to keep my squared term, my a value, positive. So I'm going to factor out a GCF here. There's definitely a GCF. I'm going to factor out a negative GCF, and that will turn my a value into a positive value. So the GCF of these two terms is going to be negative 16x. So I'm going to have 0 equals negative 16x. When I factor out that negative 16x, I have an x remaining from the first term, and I change the signs. So it becomes a minus 2 for the second term. All right? And then all I have to do now is set each factor equal to 0 and get my solutions. So negative 16x equals 0. So divide by negative 16. I get x equals 0, which makes sense. The dolphin should have been in the water at time equals 0. So that's my first time that the dolphin's in the water. Okay, over here on this other side, x minus 2 equals 0. Add 2 to each side. I get x equals 2. So the dolphin returned to the water in 2 seconds. Okay, so there we go on that. Now, let's look at part B. Okay, so on part B it says, determine the time when the dolphin reached the maximum height of the jump. Okay, so let's set this up here with a little bit of a picture over here. I am going to draw some water. Okay, and I'm going to use a gray dot to represent the dolphin. Just a great point because I can't draw a dolphin. Okay, so we're going to use this as a marker too. This is going to be time is 0. So this is going to be x equals 0 there for time is 0. Over here, we'll make it x equals 2. So the dolphin returns to the water here. Okay, and then the dolphin makes that kind of jump, leap out of the water. Okay, so the really cool thing about these kind of jumps is that they're symmetric. And we're going to learn a lot more about this in the next topic, so I'm not going to go over a whole bunch of it right now. But at the highest point here, that's the maximum height of the jump, right? So that's about halfway between 0 and 2, so that happens where x equals 1. So all I have to do to find out how high that is to replace 1 for x in my equation and get the value for y that accompanies that. So that's what I'm going to do over here. So I have y equals negative 16 times 1 squared plus 32 times 1. 1 squared, of course, is 1. So y equals negative 16 times 1 plus 32. So y equals negative 16 plus 32, which is 16. So the maximum height of the jump is 16 feet. The dolphin jumps a maximum height of 16 feet. Okay, well, this is the conclusion of the first video. It is probably going to be the longest of the 3. So hopefully you are able to start your first assignment, and then we will start back on video number 2, on method number 2, on how to solve quadratic equations.